Hello, class. Welcome to the studies on roots of quadratic equation. For these studies, we are going to deal with sum and product of roots, algebraic identities, and transformed root. That is what we normally call it symmetric functions. So now let's patiently move to the introduction of this particular studies. Root of a quadratic equation are values of x that satisfy the equation of the form ax squared plus bx plus c equal to 0. For example, the root of the quadratic equation x squared minus 5x plus 6 equal to 0 are x equal to 3 and s equal to 2. They are called the root because when you substitute 3 into this particular expression, your answer will be 0. When you substitute 2 into this particular expression, your answer will be 0. What it means is that these two answers, that is 3 and 2, satisfies this particular equation. For x equal to 3, we can bring the 3 across the equal sign, and the equation will now tends to be x minus 3 equal to 0. Then we can also bring the 2 across the equal sign, and the equation will now tends to be x minus 2 equal to 0. Since 3 and 2 are the roots, then these two particular expressions are factors of this quadratic expression and can also be written as x minus 3, x minus 2 equal to 0. So if we want to expand this expression, then it's going to be x squared minus 2x minus 3x plus plus 3 times 2 equal to 0. That is how the expression will be. So we can also rewrite this particular expression in the form x squared minus, when you see the expression here, I have factorized the x and the minus outside, then the inside the bracket can be written as 2 plus 3, plus inside this bracket 2 can also be written as 3 times 2 equal to 0. So these 2 and 3, 3 and 2 are the roots. So as such, what are the roots doing here? And what are the roots doing here? What operation is combining this root at this section? And what operation is combining this root at this particular section? So it means that there is a sum between 2 and 3. And there's also a product between 2 and 3. So it means that if I have the root, then quadratic equation can be rewrite as x squared minus sum of the root, as you see here, x plus the product of roots equal to 0. So this is the introduction of this particular studies. Now, let alpha and beta be the root of quadratic equation ax squared plus bx plus c. This time they are not numbers, but they are variables representing the root in a general form. So if we are going to repeat the same process from the first slide, then we need to understand that we can also factorize the a out of this particular equation for us to get an expression of the form a squared plus b over ax plus c over a equal to 0. That is factorization. It means when you multiply the a across this particular expression, you end up getting this expression back. So we divide both sides by a to have an expression x squared plus b over ax plus c over a equal to 0. So let's make this particular expression equation 1. Then we should remember that quadratic equation is in words being put as x squared minus sum of root x plus product equal to 0. So here we can also rewrite the expression since alpha and beta are the root. Then the equation will be x squared minus alpha plus beta x, that is the sum, plus alpha beta, that is the product, equation 2. So when we compare equation 1 and 2, what are we going to analyze here? We are going to realize that this minus alpha plus beta is the same as b over a in equation 1. And as such, when we divide both sides by minus, we are going to get alpha plus beta equal to minus b over a. So it means that the sum of the root can also be attributed to get an expression of the form minus b over a, where b is the coefficient of x and a is the coefficient of x squared in the quadratic equation. Then at the same time, when you compare the product here, alpha times beta here, is the same as the expression c over a. So we are going to bring this idea into algebraic identities of quadratic expression, which we normally call it symmetric function or symmetric expression. So let's look at the first symmetric expression. When you have alpha 1 over alpha, where alpha and beta are the root, plus 1 over beta, it can be put in the form alpha plus beta divided by alpha beta. And when we have alpha squared plus beta squared, it can also be put in the form alpha plus beta all squared minus 2 alpha beta. What is the proof? For this one, the proof is you solving or simplifying two fractions where you are going to get alpha plus beta divided by alpha beta, which is the LCM of this fraction. But what is the proof for this particular symmetric expression for the point 2? Now let's look at the proof at this section. If we have alpha plus beta all squared, it will be expanded as alpha squared plus 2 alpha beta plus beta squared. So what we need to do is to make alpha squared plus beta squared the subject. So we are going to maintain them at this side, then bring this particular expression across the equal sign, and we end up getting this particular expression as an expanded expression for alpha squared plus beta squared. Now let's move to the third option, which is alpha minus beta all squared, which will also produce alpha squared plus beta squared minus 2 alpha beta. And we have the expansion for this particular expression as our point 2. So we just have to substitute them and we simplify the expression to get the sum minus 4 times the product. All what we are doing in this particular symmetric expression or algebraic identity is such that we are interested in getting sum of root, product of root, sum of root, product of root, sum of root, product of root, and so on. This repeats itself consistently. Now, let's look at another symmetric expression of 1 divided by alpha squared plus 1 divided by beta squared. So, using fractions manipulations, we are going to end up with alpha plus beta all square because we get alpha square plus beta square as LCM, minus times beta square as LCM. So when you apply the rule of indices, it can be alpha beta all square. Then remember, we are going to get the top to be alpha square plus beta square. And this one represents the point 2 expansion. So how are we going to get the sum and product? That is what we already have here. So as such, our alpha minus beta will also be root of alpha plus beta all square minus 4 alpha beta. We got the idea from this section. That is rooting both sides of the equation. Then we can also have an expression of the form alpha square minus beta square, which is also be put in the format of difference of two square expansion. That is alpha plus beta or alpha minus beta. So this is sum and this is difference. So we need to also expand this. So how do we expand this? By substituting this expression back here, back at this side into this particular position. So here we can also write alpha cube plus beta cube being expanded in this form. So if you look at this particular algebraic identity, we expand them based on the sum and based on the product. Good. Now, for example, if alpha and beta are the root of the quadratic equation 2x squared minus 6x, 2x squared minus 6x plus 1 equal to 0, we are supposed to find the value of. So here we are interested in finding the identity alpha square plus beta square. So we have to remember that alpha square plus beta square is expanded in the form of sum square minus 2 times product. So what are we going to do? From the equation, we have a to be 2, b to be minus 6, and c to be equal to 1. So here we have to remember that per our analysis, alpha plus beta, the sum, is equal to minus b over a. So we substitute the b and the a, and we end up getting an answer to be 3. When we do that, we also find the product, and the product will be c divided by a. And remember, c is 1, a is 2. Then we end up getting 1 over 2. So when it happens, then we have to go back to the expression and substitute the sum value and the product value. When we do it, we are going to get 3 squared minus 2 times 1 over 2, and the answer will give us 8. So that is how we've been able to evaluate this particular symmetric expression based on the quadratic equation given to us. So we can also repeat the same process in this particular expression, where we want to evaluate this value or find the value of this symmetric identity using this particular equation or quadratic equation. So here we have to remember that the sum is 3 and the product is 1 over 2. So we substitute them at where they are supposed to be, simplify this expression, and our final answer will be 32. So now, if alpha and beta are the root of the equation this, we are still finding the value of alpha k plus beta k. How do we expand this particular algebraic identity based on the sum and product? So based on the sum and product, this one will be alpha plus beta power 3 minus 3 alpha beta times alpha plus beta. So if you remember the expansion, so you put the sum here, put the product here, put the sum here, and at the end we are going to get the answer or the expression to be sum power 3, 3 power 3 minus 3 times 1 over 2 times 3. When you evaluate this expression, we end up getting 45 divided by 2. So here, we are going to also learn how to form new quadratic equation from transformed root. So the roots of a particular quadratic will be given to us, and we are going to form a new equation, but this time the root will be transformed into a new format. Let's see how this will go. So transforming root simply means changing the format of root of quadratic equation to form new quadratic equation. So we are going to have old quadratic equation, then we change the root of the old quadratic equation to form new quadratic equation. So the transform root will be substituted in the quadratic word form. As it says, the word form is in the expression x squared minus sum of root x plus product equal to 0. So here, when forming the new quadratic equation, what do we do? Identify the transform root of the equation. So you need to identify them first. Then find the sum of the root and product of the root respectively. Deal with them sequentially. Then substitute the results in the expression x squared minus sum of root x plus product of root equal to 0 to obtain the quadratic equation. Now, let's see an example. If the root of the quadratic equation 3x squared minus 5x plus 2 equal to 0 are alpha and beta, form equations whose root are, it means that this old quadratic equation, these are the roots, but they are going to transform this root. They've transformed the root into this format. So what do you think the equation will be? Now, these are the steps from the quadratic equation given. We have to understand that a is 3, B is -5, and C is 2. So A plus B, which is the sum of the root, will be minus B over A. So sum of the root for this equation will be -5 minus -5/3, which will be 5/3. Then the product, which is C on A of this particular equation, will be 2/3, which means when you sum the root, you get 5/3. And when you multiply the root, you get 2/3. Now, we are going to form a new quadratic equation using this particular root. It has been transformed. So if I want to form the new quadratic equation, it means I need to find the sum of this particular root. So the sum of the root will be 1 over alpha plus 1 over beta. Remember, this is an identity, and it is being expanded and simplified as the sum over the product alpha plus beta over alpha beta. So I'll just substitute the sum of this old quadratic equation, which is 5/3 here, then the product also at this section. Then we are going to end up with 5/3 divided by 2/3, and the answer will be 5/2. It means the new equation that we are going to form, which their root has been transformed using this particular equation. When you multiply their sum, the answer will be 5 divided by 2. Then let's repeat the same process for the product. So we are going to multiply these identities, or this root rather, so which will give us 1 over alpha times 1 over beta. I hope you are understanding this concept. And it will be equal to 1 divided by alpha times beta. It is multiplication of fractions. So as said, remember the old quadratic equation have a product root of 2/3, and we substitute them at this section, and we are going to end up to have 1 over 2/3, giving us 3/2. So now the new equation will be x squared minus sum. So how much, or what value did we get for the sum? We got an answer to be 5/2. So we substitute 5/2 here as the sum plus the product equal to 0. Then we simplify this expression to remove the fraction by finding the LCM, which at the end we are going to get 2x squared minus 5x plus 3 equal to 0. So this is the new equation that was being transformed. That we formed this equation as a result of the transformation of the root of this particular equation. Now, let's see the proof. So we have alpha equal to s equal to alpha, which is equal to 2/3, and another s equal to beta, which is equal to 1. So when you solve this quadratic equation, the root will be given as s equal to 3/2, which is equal to 1/2/3, equal to 1 over alpha, and s equal to 1 equal to 1/1, which is equal to 1 over beta. So this represents the proof. So which means that the equation, this equal to 0, transform the root of the equation in the form 1 over alpha and 1 over beta. So remember, these are the root of the old one, and this becomes the root of the new one. So now let's try another example. Using the same old quadratic equation, we are supposed to form new quadratic equation whose roots are alpha squared and beta squared. So we are going to repeat the same process by finding the sum of roots, which the expansion will be this. We put the sum, we put the product, then this is our answer. Then we also find the product of roots. The product of root will be this nature. We put the product here, then simplify, we get 4/9. Then the new equation will be x squared minus sum x, that is 13 on 9x, plus 4/9 equal to 0. We simplify to get an expression of this particular form, that is 9x squared minus 13x plus 4. So this brings us to the end of this particular studies. Continue to receive the best of high school maths education from this particular channel by subscribing to the channel. Thank you.